Thanks for your interest in this talk. My name is Joel, and I'm a PhD student at ETH Zurich in Switzerland. I'm going to be presenting a work in progress titled Off-Policy Learning of Dynamic Content Promotions. And this is a joint work together with my supervisor, Stefan. What you see here is the front page of the New York Times website and a quote by their chief technical officer in 2019 regarding the challenges they had in content curation of this page. So I'm going to read the quote. Curation of this page remains a core value of the product. Trying to personalize the surface, we kept finding resistance to monkeying with the layout because it actually had curatorial value that our users value. So on this front page, the only content that is algorithmically personalized to users is this ribbon here of these 3 articles. All the other content on the New York Times front page of the website is chosen manually by humans. So we also know that several tech companies now rely on human creation of the news product, for instance, Apple News, besides the algorithmic personalization offers. So how then can we curate content using humans? So historically, and still the most common way to do so, is by relying on the expertise of editors. And the editor's picks problem, as we call it, is the problem of how to choose which content to feature on own distribution channels, such as user engagement, is maximized. So for instance, an own distribution channel is the editor's picks column on the website front page, the Twitter channel, and email newsletter here as the morning briefing by New York Times. This is a very challenging problem to solve from a statistical inferential point of view, because in most modern applications, the editors are facing vast amounts of data on user engagement. They have metrics, clicks, conversion rates, duration metrics, and it's not obvious on which of these features they should base their decision. Shall they promote content with many clicks, or that content that readers read for a long time, and so on. And they also have a lot of different choices. They can choose to promote content on the front page, on the Twitter channel, or in the email newsletter, or perhaps all of them. And which content shall they show where and in what order, and so on. So typically, some kind of decision support is needed. So how we attack this problem is by dynamically optimizing when to promote which content where. So just a brief overview here about related research in marketing and information systems. So one stream, which is quite big, is concerned with personalization via targeting, website morphing, and recommender system. This does not address the editor's picks problem because we're not trying to personalize the content. And in many situations, that is not even possible. For instance, a newspaper or a content publisher cannot personalize which content to tweet about. They can only choose, I want to tweet about this content, and then it will be shown to all users that visit their Twitter page. And the second stream concerns display and banner advertising and how to optimize that. Also does not address the editor's picks problem, since this stream of research is concerned about advertising, whereas we want to optimize, our own content. And many of the methods used in these research streams are based on randomization, such as multi-arm bandits, A/B tests. And that is generally not suitable for the editor's picks problem, because a newspaper, for instance, would generally not want to randomize which content to tweet about. So what we do is that we frame this problem as an off-policy learning task, or batch reinforcement learning task, if you will, and then provide a method for learning optimal dynamic content promotions. So for our empirical application, we are partnering with a leading national newspaper that has a daily readership of about 500,000 people, and it's active on 2 different markets, for which it has 2 different front pages with different content. And the current practice there is for the editors to, given some data about user engagement, choose which content to promote. We have access to data from this system, and we have data on 4 weeks at an hourly level, covering all articles published during that time. The data also includes all the information that was available to editors, so we can control for every factor for which they chose which content to promote, and then we observe all of the actions, all of the promotion decisions that they made. And the goal then is to learn an optimal promotion policy. That is, learn a policy that tells us how to best or which content shall be shown on the website front page of this market and this market separately. So we're phrasing this decision problem as a Markov decision process, where in the first step, some content is published at time 0. Then in time 1, the users engage with this content after it's been published. That results in some state, and a state includes, the user engagement of the clicks and so on. And given the state, the editors take an action A1 here, given the first state. And the action variable is a choice. You can either promote content or not promote it. Whatever action you take, you get a different new state. Since if you promote, you generally get more user engagement. Then given this decision, the editors then in the next period, time 2, make a new decision. And then the process continues like this over time. And we wish to optimize on this process. So our approach follows a 3-step procedure. In the first step, we shall estimate the promotion uplift, because only by learning, what is the causal increment from promoting content, can we of course know if it's good to promote content or not. But this is challenging because we're facing an endogeneity problem. As you saw from the previous slide, content is not randomized to be promoted or not, but the editors chose, which content to promote on the basis of the state. So our solution to this then is that we condition on the state. So we model what is the response in the user engagement. How will user engagement increase if they promote, given the previous the state of the previous period. And then we also estimate what is the probability that the editors would have promoted content given the state. And since they took the decisions on the basis of the state, we're able to control for all the things. And thus we get, once we condition on this, have as good as random promotion decisions. And then using this, we get what is known in causal inference literature as a doubly robust estimate. That means that to get an unbiased estimate of the promotion uplift, only one of the first model and second model needs to be correct, actually. So that's sort of a robustness property that is very good. And in the second step, we then wish to estimate how the uplift varies across content and time. Because only by learning this can we, of course, choose which content is better to promote than other content. So what we then do is that we take the uplift estimate on stage 1 and we model it as dependent on some state level variables. So for instance, you might believe that it's the number of clicks and who wrote an article that explains if it has a great uplift if it is promoted. Then you should manually choose those two features as the heterogeneity determinants, and you will see to what degree do these features explain the heterogeneity uplift. What you can also do is they can select them in a data-driven manner. So, for instance, if you saw the last, so you get back the estimate or the variables that estimated to explain the uplift heterogeneity. So our framework actually does not a priori assume that you know even the functional form or even which covariates explain the uplift heterogeneity. So it's fully data-driven. Then in the third step, we're solving the decision problem. Which content shall be promoted? So what we then do is that we estimate the uplift for all content at a given point in time that can be promoted, that is in our choice set, so to say, and then rank the content with respect to uplift. So if we only can promote, say, 10 articles on the front page, because that's all we have space for, then the optimal decision or the base optimal decision rule is to promote the 10 articles that have the greatest uplift. And we show that this is optimal decision in favor. So here I show some preliminary results on holdout test data. So what I do is that I follow our estimation procedure as explained in the previous slide on training data, and then on test data, I see how well they perform. So you see here, for this first model, I used a linear fixed effects panel model with lasso, the choose covariates. For this choice model, I used a discrete choice rigid. And then for this uplift heterogeneity model, I also used a linear fixed effects model. So this is just the simplest sort of data-driven estimators to get some robust estimates. And what you see here is that if we follow the procedure, estimation procedure, as I've explained it, our framework, then we get the highest possible, the highest average user engagement. And if you then, here I compare it to some different baselines. So for instance, if you would follow our procedure, but instead of in this ranking which content to promote on the basis of the expected uplift, but instead you take like a risky strategy and you rank content on the upper confidence bound of their uplift, then you get a little bit worse than the promotion decisions that this results in, leads to a little bit lower average performance score. And you lose a little bit more if you take the risk-averse strategy, instead rank on the lower confidence bound. And actually, if you follow the so-called top N method, that is the standard method in the recommender systems, as far as I know, then the user engagement or average user engagement you get from the promotion decisions does not even beat the current manual practice of the editors. And here we also see how this is over time. So I simply plotted how the average user engagement is over a given day. And then what you see here is that our policy red line results in a higher, at each point in time, it results in a higher user engagement than all other methods that we consider. So what have we done in this paper? We have proposed an off-policy learning framework for the editor's picks problem. Our method is flexible and still very robust. And then we demonstrate its impact in a large-scale empirical application. And we believe this framework, as we explained it, is also widely applicable to other multi-channel dynamic content promotion policies. And what we're working on now in the paper is to do a field experiment where we showcase this in practice. Thanks a lot for listening.